Hi, this is Victor and welcome to my math tutoring channel. In this video, I will start explaining the integral calculation, and I'm starting from scratch. I will start explaining the chapter, and then we will do some exercises. This is the difference between me and other videos, because other videos solve exercises. No, me, I want you to understand the chapter first, and then we solve exercises together. The purpose of integration calculus is to study the area under a curve. Let's say, to give you a practical example, let's say a bacteria is growing at a rate of whatever, e to the power of x2 plus 1. So you draw that graph, and they want to study the population that was affected between time equal 1 month and then 5 months. So you draw the graph, and then you will do the area under that curve using the integration. But we will start by ABC first. We will study the area under the curve, dividing it into a rectangle. You're gonna see what I mean. Let's start. So if I want to study the area under the curve of the function y equal x squared, yeah, so I draw it. It's gonna be like this, and I want to study it between time 0 and 3. Yeah. So to study the area under the curve, if I divide the area with a rectangle, 1, 2, 3, 4, 5 rectangle, let's say. If I study the area of those rectangle, I will have an approximately what is the area under the curve. But as you see, if I study the area of that rectangle, I will be skipping this. Of that rectangle, I will be skipping that area. I will be skipping that area. And here, for that rectangle, I will be adding this area. Anyway, if you want to be accurate, you divide your area under the curve to infinity of rectangle. When it is infinity of the rectangle, like the skipping is like almost inexistable. And we will demonstrate that by dividing the area under the curve until to an n rectangle, and then we will study the limit when n goes to infinity. So let's start with this. Here the rectangle should be equal size here. I draw them like that, but like the length between 0 and the first rectangle should be equal to that length, should be equal to that length, should be equal to that length. But for the explanation, it does not matter. Sorry, before we start studying the area under the curve, there is the sigma notation formula. If you can Google them, and you can find them on Google, or I will give them to you, and because we will be using them while studying the area under the curve. So the sigma notation formula, there is 7 formula. Formula number 1 is sum for n equal 1 to infinity, 1 to n of 1, it's equal to n. Because like for n equal 1, but this is the sum, it's gonna be equal 1 plus 1 plus 1, n times, so 1 times n is n. That's obvious. The second formula will be the sum, sorry, here it's not, here it's I equal 1 to n. I equal 1 to n of I. This will be equal n plus 1, and divided by 2. You don't need to understand how I came up with this formula. We will see it in one exercise later on, but you just need to apply the formula in your while solving the problem. So the third formula, sum I equal 1 to n of I squared, it's equal n times n plus 1 times 2n plus 1, and all that divided by 6. And here you see the n that is here, it is the n that is there. So the n that is here, it is the n that is here, the n that is here, and the n that is here. So if I have sum I equal 1 to n minus 1, so that n will be of I squared it become n minus 1. That the first n. The second one is n minus 1 plus 1. And the third one, 2 n minus 1. I replace n by n minus 1 plus 1 divided by 6. So you have to be careful for that. The fourth formula would be sum I equal 1 to n of I to the power of 3. This is equal n square n plus 1 square and divided by 4. And I still have 3 formula, and then we start the exercise. The fifth formula, sum I equal 1 to n of I to the power of 4. This is equal n plus 1, 2n plus 1, 3n square plus 3n minus 1, and divided by 30. The sixth formula, the one before the last, sum, there is more, but like those are the formula that are used the most, to n of 2i, it's equal n plus 1. And again, if I have n minus 1 here, I replace all the n by n minus 1. Okay, and the last formula, formula number 7, for I equal 1 to n, 2i plus 1 of 2i plus 1, this is equal to n square. So as I said, you don't need to prove the formula, you just need to use them. Now let's go back to our exercise, which is this. Okay, cut. Actually, I will add it over there. I'll draw it. So let's start a new page. So I have, this is y equal x square, and I'm studying it between 0 and 3. And as I said, I want to divide it into 5 equal rectangle. 1, 2, 3. Okay, that looked better. And if I continue it, that's my first rectangle, that's my second, that's my third, and that's my fourth, and this is a rectangle here. And again, I repeat, if I divide it into an infinity of rectangle, I will be accurate, because here I'm not getting that area, but I'm adding this area here. Because I divided it into 5 rectangle and the original value is 5, so here it is 3 over 5. The distance from here to here, and the distance from here to here, it's 3 over 5. And the x here is 0, and the x here is 3 over 5. The x here is 6 over 5. And the x that is here is 9 over 5. And the distance is always 3 over 5. 3 over 5. 3 over 5. So if I want to have the area under this curve, all what I have to do is to have the sum of the area of the 5 rectangle that is here. I will do it, because it's an approximation, I will have it more accurate if I start the first rectangle, its height equal to 0. The height, because y equal to 0 here, the height of that, because I have y equal x over 2, so here would be 3 over 5 square, its height, and the height of that rectangle will be 6 over 5 square. F of 6, well, because I replace x by 6 over 5, so it becomes 6 over 5 square, or f of 6 over 5. It's the same thing. So it becomes 6 over 5, and you continue like that. So the sum of the rectangle will be equal, I'll call it S, it's equal, because the width here is 3 over 5, and I'm starting, the first time I will start from here to here, and then I will do another sum starting from that point to this point, and the area is gonna be between those 2 points. So f of 0, because I start with this point, square, because like my function is x square here, not x2. Well, which is f of 0, but like it's gonna be at the end square, plus again the distance between here and here is 3 over 5 multiplied by f of 3 over 5. So 3 over 5 multiplied by f of 3 over 5, plus again the distance here is 3 over 5, and I'm multiplying by f of 6 over 5, plus the distance here is 3 over 5 multiplied by f of 9 over 5, because the x that is here is 3, 6, the x that is here 3, 6, 9 over 5, and the last one, because I have 1, 2, 3, 4, and I divided it into 5 rectangle. Again, the width here is 3 over 5 multiplied by f of 12 over 5. 3 over 5 multiplied by f of 12 over 5. So my sum would be equal, and I will put the line under the S, because this is the lower value of my area, and then when I start from here, I will put the sign, the line above the S. S of n equal 3 over 5, and now I have to replace x by 0 here, 0 square times 0 square plus 3 over 5, and I replace x by 3 over 5. The x that is here, I replace it by 3 over 5, so it becomes 3 over 5 square plus 3 over 5, I'm doing this, multiplied by 6 over 5 square, because of this, plus 3 over 5 multiplied by f by 9 over 5 square, by 9 over 5 square, plus 3 over 5 multiplied by 12 over 5 square. Again, I repeat, this is 3 over 5, and here 3 plus 3, 6, 9, and this is 12 over 5. So if I do that, my Sn will become, this one will become 0, because 0 to the power of 2 is 0, time whatever is 0. And the second one will become 3 over 5 times 3 over 5 square. The third one, now my 6 here, I want to write it in a more intelligent way. 6 is 3 times 2. So, I don't know why I put equal here. It's plus. So I'm doing this, the third one. It is 3 over 5 times 3 times 2 over 5 square. But the 2, I will take it outside my parentheses. It become 2 over square outside my parentheses, or it become 4. So I wrote it so for you to understand what I am doing. So it is 3 over 5 square times 4. And the third one here, it is 3 over 5, and the 9 is 3 to the power of 2. So I will put 3 over 5, the first one, and then it will go out by square times 9, because I had f of 9 over 5, y equal 9 over 5 square. It become 3 over 5 square times 3 square, and the 3 square is 9, plus 3 over 5, and the 12, let's do it here, and I will erase it after, or I'll do it here. 12 is 4 times 3, and the 4 is 2 times 2. So the 12, I can write it 3 times 2 times 2 times 2 square. So it is 3 over 5 square, and I have 2 to the power of 2, but again, because I have the square here, it becomes 2 to the power of 4, and 2 to the power of 4, it's equal 16. So now I can factorize 3 over 5 to the power of 2, because it exists in every sum. So my Sn is equal 3 to the power of 5. Actually, I can factorize to the power of 3, because I can, this times this is 3 over 5 to the power of 3, 3 over 5 to the power of 3, 3 over 5 to the power of 3. So I will factorize 3 over 5 to the power of 3, and the first one I have to put 1, the second one it is 4, and the third one it is 9, and the last one it is 16. Now, if I don't want to use my formula, I will show you how to use the formula. Anyway, if I add this, 1 plus 4 is 5, 9 plus 16 is 25, plus 5 is 30, so my Sn is 27 divided by 125 times 30, because 3 to the power of 3 is 27, and 5 to the power of 3 is 125. And if you do your calculation, it become 6.48 units square. Yeah. But now I want to come back here, and I will explain for you the one formula. I can write Sn equal 3 to the power 3 over 5 to the power of 3, sum I equal 1, and I have 1 term, 2, 3, 4 to 4, and I realize 1 is 1 square, and 4 is 2 square, and 9 is 3 square, and 16 is 4 square. So it is I square, because if I equal to 1, I have 1 square, which is 1. If I equal to 2, I will have 4, because 2 to the power of 2 is 4. I equal 3, I have 9, and I equal 4, I have 16. Now I want to apply the formula that I just gave you, and the formula said the sum of I equal 1 to n of I square equal n times n minus, actually here I to 4, not I to n, because I have the 4 here, so I have to put the 4 there, and then it become here 4 minus 1, and then the last one it become 2 times 4 minus 1 plus 1 divided by 6. So it is equal 4 times 4 minus 1 is 3, and 2 times 4 is 8, plus 1 is 9, and divided by 6. So my formula, so it becomes 4 times 3 times 9. Yeah. So my formula become my Sn, the lower bound of my formula, is equal 27 over 125, which is 3 over 5 to the power of 3. And instead of writing this, I can write times 4 times 3 times 9 divided by 6. And if you multiply 4 times 3 times 9 times 27 divided by 125 times 6, you will have exactly 6.48 units square. And I'm sorry, I'm writing, so this is divided by 6 here. Okay? Now we studied the area under the curve, but I start from here. The second time I will start it from here and I will end it here, and my area under the curve is gonna be between 6.48 and whatever value I'm gonna get when I finish my my calculation. So again, the Sn, now the upper bound, is equal 3 over 5 because I divided it into 5 area. But instead of starting with f of 0, I will start with f of 3 over 5 because now I'm starting, that's my height, plus 3 over 5 and f of 6 over 5 plus 3 over 5 times f of 9 over 5. Again, my rectangle, it is now this times height times width, and this is 3 over 5, this is 6 over 5, the x here, and the x here is 9 over 5, 12, and then I will end up with 15 over 5. Plus 3 over 5 times 12 over 5 plus 3 over 5 times 15 over 5. You do the same logic that I did here. It's exactly the same thing, and you do your calculation, and you will find that Sn is equal 11.88 units square. Yeah, you can apply the formula, or you can do it that way. So the area under my curve, the area will be between 11.88 and whatever answer we had here, which is 6.48. 6.48. Now, if we divide the area under the curve to an infinity of a rectangle, you will see that I will have exactly the area under the curve. So here, if I have the same one, y equal x squared, but I will divide it to an infinity. You see, if I divide it like this, I will miss that, but now, like, I'm almost missing nothing. So my area under the curve, Sn, equal 3 over n, because the previous one I divided it into 5 rectangle. Here I'm dividing it into n rectangle, times f of 0. I will do the lower bound starting with this till n minus 1, and the second one I will start with 1 to n, plus 3 over n times f of 3 over n plus 3 over n times 6 divided by times f of 6 over n plus 3 over n f of 3 times n minus 1 divided by n minus 1. Again, f of 0 is 0 because I replace x by 0. 0 multiplied by whatever is 0. So my sum will become 3 over n, and my second term will be times 3 over n squared. And my third term plus 3 over n times 6 over n squared, because if this is 3 over n, this is 6 over n. We saw the logic before. And if I continue till 3 over n, and it become, because this is 3 over n times 3 over n to the power of 3, and then like before the 6 I will put it 3 to the power 3 times 2 to the power of 2. The 2 to the power of 2 would go outside the parentheses, and it becomes 3 to the power of 2 over n multiplied by 2 to the power of 2 outside the parentheses. So my last one will be 3 to the power of n of 3 times n minus 1 square. So my Sn will become 3 divided by n to the power of 3 sum of k equal 1 to n minus 1 of k square. And if I want to apply the formula, my Sn, it is equal to 27 over n cube times, I will start, because I have n minus 1, so my formula would be, let's see the formulas, I have them written here. So my n will be n minus 1, the first one. The second one will be n minus 1 plus 1. And the third one will be 2 times n minus 1 plus 1 divided by 6. And my Sn will become, my sum, Sn will become 27 over n3 and multiplied by n minus 1, and this will become n, and this 2 times n is 2n minus 2, so this becomes 2n minus 2 plus 1, it's 2n minus 1. 2n minus 1 divided by 6. And that's my area under the curve when I divide to n rectangle. And the answer is u square, unit square. And this is, I started with f of 0. The next one, I will start by 3 over n, but multiplied by f of 3 over n. I will start the second one, I won't start from here, I will start with the first one, and I will end to n with n. So if I plus 3 over n multiplied by f of 6 over n here, over n till the end, and my limit will be, my sum would be 3 over n to the power of 3 times, let's say, k squared, but this time k start from 1 to n. The previous one, my k start here, here my k start from 0 to n minus 1. And my Sn is equal 3 over n, or 27 over n to the power of 3, and multiplied by n minus 1, 2n minus 1 divided by 6 unit square. So my area will be between I have to shrink it first so it fits, because I'm lazy, I don't want to rewrite it here. There is no minus. And where did I write the formula? And this one here. Okay, and I'll rewrite it. 3 over n to the power of 3 sum k equals 0 to n minus 1, and it becomes n minus 1 times n times 2n minus 1 divided by 6. So my area is it will be in between those two. So now let's study the limit when my area goes to when my n goes to infinity, and we will have the exact length. So let's start with this. Yeah. So I want to study the limit when n goes to infinity. 3 to the power of 3 is 27 divided by n to the power of 3 of n times n minus 1 times 2n minus 1 divided by 6, and you will see that I will have the exact value of my of the area. So I will start by developing n times n minus 1. So it is the limit when n goes to infinity of 27 divided by n3 multiplied by n square minus n times 2n minus 1 divided by 6. And now I want to develop this parenthesis. So it becomes the limit when n goes to infinity of 27 divided by n3, and this become n2 times 2n, 2n to the power of 3 minus n square minus 2n square plus n. Now I have those two, so the limit when n goes to infinity of 27 divided by n to the power of 3, so 2n to the power of 3 minus 3n to the power of 2 plus n. And here inside the parentheses I want to factor out n3 to be able to take it out with this. So it is the limit when n goes to infinity of 27 divided by n3, and here I want to factor out n3. The first term becomes 2 minus 3 divided by n, because n3 times 3 is 3n3 divided by n is 3n2, so I come back to where I used to be, plus 1 divided by n n square. Now I can simplify this n3 and n3, so the limit when n goes to infinity is equal, there is divided by 6 here. My formula, I forgot to put divided by 6 here, so the divided by 6 here. So 27 times 2, when n goes to infinity, this goes to 0 because 3 divided by infinity is 0, and this goes to 0 because 1 divided by infinity is 0. 2 divided by 6, so it becomes 27 times 2 divided by 6, which is equal 9 units square. And if I want to study now the other limit, now we study the limit of when k equals 0 to n minus 1. If I want to study the limit when n goes to infinity of 3 over n to the power of 3, sum of k equal 1 to n, I square, it is equal limit for n goes to infinity, 27 over n to the power of 3, and it become here n times n minus 1 times 2n plus 1 divided by 6. That's the formula I'm applying, and you follow exactly the same logic that we followed here. We follow exactly the same logic that we followed here, and you will have it's equal 9u squared. So the lower bound is equal to the upper bound, and that's how we find the exact limit. Thank you for watching. If you like my video, please subscribe to my channel. This is a way that entice me to do more videos like that for you, and it's beneficial for you, so you will understand the material and pass your course. Thank you.